Alright, so in this video, we're going over 1.3, the elements of group 1. So here is our learning objectives. Hopefully, after this topic, you will be able to interpret data to describe the patterns and the properties of the group 1 elements and use patterns to predict the properties of the group 1 elements. So we have three pictures over here. We have a mobile phone battery, an engine lubricating grease, and we have red fireworks, and we have to know the difference between them, or what firstly, what do they all have in common? So they all rely on compounds of lithium. Lithium is in group 1 on the left of the periodic table. So we have the full periodic table. On the periodic table, lithium is on the left side, and the lithium is on the left side. In group 1, the first element is lithium. Metals are on the left side of the periodic table, and the non-metals are on the right side of the periodic table. We have a step line in by boron just above aluminium on the periodic table, and that anything to the left of that step line is known as metals, and anything to the right of that step line is known as non-metals. Anything near that step line is known as metalloids. So all group 1 elements like other elements or like other metals, the group 1 elements are to the left of the step line. This shows that they are metals. In many ways, group 1 elements are like other metals. They are good conductors of electricity and heat. They are shiny when freshly cut. So in some ways, group 1 elements are different to other metals. The table over here shows that group 1 elements have lower melting points than other metals. Later, we will be looking at boiling points as well, but first let's focus on the melting points. So these are the elements. First, we have lithium, then we have sodium, potassium, rubidium, which are all in group 1 elements, and then we have copper and platinum. These are not in the group 1 elements. So we have the melting point of all of these, and you might have already noticed that the copper and platinum's melting point has way significant difference to the melting points of the group 1 elements. So lithium has a melting point of 180, and then sodium has a melting point of 98. Potassium has a melting point of 64, rubidium has a melting point of 39, but then copper and platinum have a huge melting point of 1083 and 1796. And this is one of the differences that you can state in exam. This is the periodic table. Lithium is over here. The step line, well, if your periodic table does not have a step line, then it technically has an imaginary step line. And so the step line is right here, just above aluminium, and by boron, and it goes all the way down to Pb. And anything to the left of that is metals, anything to the right of that is non-metals, and anything near that is known as the metalloids. So this is one question that can come up in your test. It's to state one way in which group 1 elements differ from other metals. And you can say the melting point has a huge difference, and you can state what we learned in this table over here. Are there patterns in the group 1 properties? So the group 1 elements showed patterns in physical and chemical properties. So there's two properties over here, physical property and the chemical property. So in the physical properties, the data on the opposite page, which we looked at before, the table which we looked at, which is this table over here, is showing that the melting point decreases from the top to bottom of group 1. So from lithium all the way down to rubidium, it decreases. And then the table below over here shows the boiling point also decreases from the top of group 1 to the bottom of group 1. So from lithium to rubidium is 1330 to 688. It's a huge difference, and it's showing how the boiling point decreases from the top to bottom of group 1 as well. This is another question that you can get in your test. State what happens to the boiling point as you move down group 1. As you move down group 1, the boiling point also decreases, as we learned from this table over here, and you can see the values as well if you want. For lithium 1330, sodium 890, and so on. So here are the chemical properties. So here are the chemical properties. So the group 1 elements are very reactive. This means that they can easily take part in chemical reactions. So all the group 1 elements have exciting reactions with water, especially the elements that are on the top of the periodic table. So from lithium, and then rubidium will have the least reaction from group 1 elements. So the gas moves the reacting element around on the water, and the reactions also make alkaline solutions. So the universal indicator turns purple. You can use this formula sort of thing over here. It's known as lithium plus water to lithium hydroxide and hydrogen. It can be very useful, and there is a pattern in this formula. So they always produce hydrogen and a metal hydroxide. So they produce hydrogen, at the end you have plus hydrogen, and they produced a metal hydroxide. In this case is lithium hydroxide, and then you have lithium plus water, which is the reaction in the beginning. So lithium, since it's at the top of group 1, it has a good reaction with water, so it's very, very vigorous. Then potassium, which is I think it's next, it has is a third one. I think that also has a very vigorous reaction. So name the gas produced when group 1 elements react with water. You can use this formula over here, the gas produced, and you can get the answer from here. And the Kerboodle book, this book is actually very useful if you want to know any of the answers or anything. I think it also has the answers at the back if you want, so you can use them as well. And here are the summary questions. So write 5 character sentences from the sentence starters and enders. So you have the sentence starters over here, and you just need to match them with the sentence enders. So we have question 2. The table gives hardness values for some group 1 elements. The bigger the value, the harder the element. So here are the elements: lithium to cesium, and you have the metals hardness. So lithium 0.6, 0.5, 0.32. So you have to plot the hardness values on a bar chart. So we looked at this before, previously in last session, I think it was 1.2. We looked at the bar charts, what bar charts are as well. So that can be very useful to make a bar chart over here. And you can describe the patterns in hardness, and you have to predict the hardness of potassium. And you have to explain your answer. You have to always justify your answer. Then you have question 3. It's a bit more harder one. You have to describe in detail the patterns in the physical and chemical properties of the group 1 elements. From one is probably the easiest question over here, and then you can get 5 marks. But if you want a little advanced, you can go to question 3, where you can probably get 6 full marks. And that's pretty much it for this video. Thanks for watching, and I'll catch you in the next video.